Now start with new chapter, chapter 2, Electrostatic Potential and Capacitance, class 12 physics. What is electrostatic potential? In electrostatic potential, the electrostatic potential at any point in an electric field is equals to the amount of work done. Amount of work done per unit positive test charge from infinity to that point against the electrostatic force without acceleration. So potential V equals to work done W divided by charge Q. SI unit is volt. 1 volt equals to 1 J by C. डायमेंशन फॉर्मूला होता है M L square T minus 3 A minus 1 and it's a scalar quantity. Electrostatic potential difference, the difference of electrostatic potential just in last definition from unit positive test charge or the 2 points in the electric field. So VB minus VA equals to W AB divided by Q naught. Now the line integral of electric field from initial position A to final position B. Initial position A है and final position B along any path is termed as potential difference between 2 points in an electric field, that is VB minus VA equals to minus integration A to B E dot dI. Now potential due to point charge, here consider point charge Q placed at point O. At point O, charge Q placed and let P at any point in the field of the above charge. R is the distance and we are consider 1 coulomb charge in electric field. Now let the distance OP equals to R. OP equals to R. Distance in last figure where we have distance between O to P is R. Then let OP equals to R vector arrow and the field P due to Q will be directed along P given by, so field क्या होगा E equals to 1 by 4 pi epsilon naught Q by R square. For arrow we can say that or 1 by 4 pi epsilon naught Q by R square R vector. Okay, so as the definition, potential P equals to work done against electric field mean moving unit positive test charge from large distance to P. So therefore force equal and opposite to the force exerted by electric field be applied on the unit positive test charge. So therefore force as external because force equal and opposite, force equal and opposite to the force exerted by electric field is to be applied on the unit positive test charge. जो फोर्स है वो क्या है? इक्वल एंड अपोजिट टू द फोर्स एक्सर्टेड बाय इलेक्ट्रिक फील्ड इज टू बी अप्लाइड ऑन द यूनिट पॉजिटिव टेस्ट charge. Okay, for unit positive test charge force external equals to minus, we have given 1 coulomb charge E, so we get minus E. So for small displacement dr, for small displacement dr, work done is dw equals to f dot dr. Work done क्या होता है? f dot dr. So therefore we have minus E dot dr. So now E is radially outward. E क्या है हमारा? radially outward है. as seen figure E क्या है? radially outward. So for radially outward, taking dr to be, first E is radially outward. So taking dr to be radially also outward. सो डी आर को भी हम क्या करेंगे, रेडियल आउटवर्ड लेट करेंगे. देन एंगल बिटवीन ई एंड डी आर, एंगल बिटवीन ई एंड डी आर become 0. Both of them, if radially outward, then angle between them is 0. So dw equals to minus e dr, putting the value of e 1 by 4 pi epsilon naught r square dr. Therefore v is equals to dw equals to minus infinity to that point. So infinity to r है हमारे पास, then q by 4 pi epsilon naught r square dr. So v equals to, taking q upon 4 pi epsilon naught, taking common we have minus 1 upon r, infinity to r. After integration we get v equals to q by 4 pi epsilon naught r, or we can say that v equals to k, q by r. k को हमने क्या लेट कर लिए, q by 4 pi epsilon naught, where k equals to 1 by 4 pi epsilon naught. This is the expression for potential due to point charge. Now potential due to an electric dipole. In an electric dipole, for an ideal dipole, the electric field varies inversely as RQ. For ideal dipoles के लिए क्या electric field vary होता है, RQ. Now we determine potential due to an electric dipole. First we consider two charges, minus q and plus q. At minus q we have A point and here B point. O is the middle point, where two differences we have A, also here A. Okay. Now consider, AB is the electric dipole. AB क्या है, इलेक्ट्रिक डाइपोल. लेंथ क्या होगी AB की, AA, that means 2A. So AB equals to 2A. AO equals to A and OP equals to R. OP क्या है, OP. Here P, OP equals to R. O and P, OP equals to R. Now in triangle OAC, in OAC, ये triangle हमारा OAC. In OAC we have cos theta equals to OC divided by OA, where OC divided by OA की वैल्यू क्या है हमारे पास, A. Therefore we have OC equals to A cos theta. Now also OD equals to A cos theta. If R greater than A, we have PA equals to PC equals to PA approximate equals to PC, which is equals to OP plus OC. PA equals to OP plus OC. OP plus OC. Okay. Here we have R plus A cos theta. Now PB approximate equals to PD, which is equals to OP minus OD. We have R minus A cos theta. So V is the potential due to electric dipole. So V equals to 1 by 4 pi epsilon naught, then Q by PB minus Q by PA, Q by PB, PB and PA. Therefore, after putting the values, we have V equals to 1 by 4 pi epsilon naught. Taking Q common, we have 1 divided by 4 PB. We have R minus A cos theta minus divide 1 by R plus A cos theta and after solving we have 1 by 4 pi epsilon naught 2A q cos theta divided by R square minus A square cos square theta. So which is equals to 1 by 4 pi epsilon naught P cos theta divided by R square minus A square cos square theta. Some cases arise here. First is if P lie on the other side, P lies when on other side, theta equals to 180 degree and cos theta equals to -1. So V क्या होगा हमारा? V equals to 1 by 4 pi epsilon naught negative term and P divided by R square minus A square. Next is when P on equatorial line, P on equatorial line, theta equals to 90 and cos theta equals to 0. So V equals to 0. Okay. If P lie on axial line of the dipole on the side of positive charge, theta equals to 0 and cos theta equals to 1. So what is the value of potential difference? For potential, V equals to 1 by 4 pi epsilon naught P divided by R square minus A square. Okay. Now potential due to system of charges. In system of charges, consider system of charges Q1, Q2, Q3 and so on Qn with position vector R1, R2, Rn relative to some origin. Like P is the origin here. The potential V1 at P due to charge Q1 is, first we have origin P, charges like Q3, Q2, Q4, Q5, Q1 and their position vectors R1P, R2P, R3P, R4P and R5P. Now potential V1 at P due to charge Q1. Due to charge Q1, we have V1 equals to 1 divided by 4 pi epsilon naught Q1 divided by R1P. R1 divided by P. Where R1P is, R1P क्या है? Distance between Q1 and P. R1P distance है between P and Q1 and R5P क्या है? Distance between Q5 and P. R4P क्या है? Distance between Q4 and P and so on. Similarly, potential V2 at P due to Q and V3 and so on. Now potential at V2 at P due to Q2 and V3 due to Q3 are given so on. Similarly for V2, 1 by 4 pi epsilon naught Q2 divided by R2P and taking QV3 1 by 4 pi epsilon naught Q3 R1P, sorry R3P, and so on. Now the potential at P due to total charge configuration, for total charge configuration is the algebraic sum of the all potentials due to individual charges. So algebraic sums means they are positives, V1 positive, V2 plus V3 and so on. ये क्या है? algebraic sum means आपस में क्या है, ये ऐड हो जाएंगे. Now putting the values in all the values, taking 1 by 4 pi epsilon naught taking common. Now Q1 R1P, Q2 R2P, and so on, Qn Rn P. This is the potential due to system of charges. Charges in electric potential energy of the third as it moves from initial to infinity is the product of third charge Q naught is the system of potential due to system of charges.